Okay, so how to make a prediction from a sample and make that prediction hold good for the entire population. So we need to do an estimation from the sample data and make a prediction about the population data in this case. And there are two types of estimates we're going to talk about, the point estimate and the interval estimate. Now, if we go back to our example of McDonald's, and so in the McDonald's example, we wanted to know what's the average income of a customer. However, when we look at this example, we see that we have only surveyed about just slightly more than 100 or about 150 customers here in this sample. But let's say that McDonald's is interested to know about the average income of all customers who visit McDonald's stores, and it's not just these 150 people. However, a survey obviously has its limitation, as we learned in the earlier video, and because we want to minimize cost of running the survey, and we don't want to spend too much time in running the survey. So we have picked up this 150 people. From this, we have to make a prediction about the number the average number of the average income of customers who visit McDonald's. We are talking about the whole population of customers. So what happens here is, when we do a summary statistics using stat tools, what we observe is a sample average. So we do a one variable summary as we did last time, and we found the sample average was $55,270. Now, this is okay as a sample mean or the sample average, but what we need to make a prediction about is a population mean, or the average of the entire population of customers for McDonald's. So how do we make that call? The sample mean we have got, which is $55,270. Is it something which is useless? No, it's actually a good starting point. Okay, so this is what we call as a point estimate. So it gives us an estimate. Okay, so if we have no other means to make a prediction, and somebody tells us that you have to give us one particular number as an average for the entire population of customers, perhaps this is the number I will go by because this is the number I got from my sample. So $55,270, which we got from the sample, is a good starting point for us. This is called a point estimate. Okay, so the X bar again is the sample average, and in this case we got 55,270. It's a point estimate for the population average, or the population mean, which is denoted by mu. It's a good starting point. It's a best guess, but we know that this is not the number which is actually correct, because if we take a different sample of 150 people, it's highly unlikely that we would get the same number, 55,270. Okay, so if people take different samples, they would come up with different sample means. So a point estimate is not really the best estimate for us, because it allows no margin for error. We just provide a simple number like $55,270, and that is our prediction. Okay, and it also does not use all the sample information, because in the sample we have seen that there's a lot more information than just the average. There's a lot of variability within the sample. Different people earning different incomes. So that information is not used in our calculation at all. We just base our prediction on the point estimate or the sample mean. So the option we choose is called the interval estimate. This is really good because this actually accounts for the margin of error. And you may have seen a margin of error appearing in predictions in the popular media. For example, when the pollsters make a prediction about an election, they generally give you a point estimate in the headlines, but they also mention the margin of error somewhere in the bottom. So if you read the fine prints, you'll get the margin of error. So for example, if somebody predicts that party A is going to get 48% of the popular vote, with a margin of error of 3%, that would mean that the actual prediction they're making is 48% plus minus 3%. That means it could be anywhere between 45% and 51% in the population, which would go to vote for party A. Okay, so that's their prediction. People often don't follow that margin of error. They just focus on the middle number, which is 48%, which is also the point estimate. But they disregard the margin of error, which is so important, because what they're actually saying could change the outcome of the election when their prediction is that people, 45% to 51% of the people will vote in a certain way. So the margin of error is most important for us to make predictions. We will always use interval estimates for our prediction. The point estimate sits exactly at the middle of the interval estimate. So for McDonald's customers, we got $55,270 as the sample mean, as the point estimate. But when we make an actual prediction, we will make $55,270 plus minus the margin of error. So what exactly goes behind the calculation of margin of error? Okay, the margin of error is basically affected by three things. One is the sample size that you selected. So if you select a bigger sample size, your margin of error is going to get smaller. Okay, so that is quite intuitive, that we will be less uncertain of our prediction if we use a bigger sample size. So pollsters can, if the pollsters want to make a prediction which is much more tighter than 45% to 51%, okay, they may like to choose a bigger sample size, if that is cost effective, okay. So if you change your sample size, you will obviously see that the margin of error will slightly reduce. The next one is variability of data. The margin of error will also depend on how variable the responses were. For example, with the McDonald's income example, how variable was the data? $55,270 was the mean, but were individual customers earning very close to that number, or you had quite a big dispersion? Some people earning maybe 20,000 and some people earning close to 100,000. So how variable the data is affects your margin of error. And obviously, the more variable the data, the margin of error will be wider, okay? Because you'll be less certain in your prediction. So you have to widen your margin of error to capture that effect. The last one is the degree of certainty that you can have on your estimates. Again, you will see all prediction made by pollsters and others will have something like a degree of confidence. Again, that is mentioned in the fine print, and most often you will see a degree of confidence used in that, which is basically 95%. 95% degree of confidence used by pollsters, but it's not uncommon in some cases in some scientific research to use a degree of confidence which is 98%. Sorry, 99%, but 95% is something of a rule of thumb we use in most cases. So again, if you want to be very, very confident in your prediction, you have to increase the degree of confidence. But that's not always going to work in your favor, because if you increase the degree of confidence, the margin of error has to go very, very wide. And for example, if I say that I'm almost 100% confident that party A will get beat somewhere between 20% and 60% of the votes, the prediction has very little value because the margin of error is so wide. Okay, so although I'm very, very certain of my prediction and I'm having a lot of confidence in my prediction, that the actual share of vote for party A will be between 20% and 60%. That prediction is not useful to anyone who is trying to understand the results of the election. So increasing level of confidence is not always helpful, and sometimes we have to give up confidence in order to get a more precise prediction. Okay, so let's look at some quick simulation exercise, and that gives you how we go from a sampling to an overall population prediction. So if we click on that link and go to simulations or demonstrations, and then choose the sampling distribution simulation. We see an exercise where there's a distribution of something with a mean of 16 and a median of 16, standard deviation of 5. Let's just build a story to make this more interesting. Let's say this is the age of kids enrolled in soccer camps around Australia, and the mean age is 16 and the median is 16. As you can see, the distribution is quite symmetric, a normal distribution, and but you can change that using a mouse. But let's start with the symmetric distribution. So let's say I'm not aware of what the mean age is, okay? Although the number is given here, let's assume that we don't know that. We don't know the population. So if we are trying to make a prediction about this population mean using just a sample from this population, how close we can get. For example, if I just pick up 5 people from this whole population and try to make a prediction. So I just pick up 5 people randomly. So I get a sample mean. You can see that sample mean is not quite coincident with the population mean, although I'm not very far off in this case. And I can go on taking, I can ask somebody to take another sample for me. And that person also took 5 people, and they got a sample mean which is quite different. So you see that how difficult it is for these 2 people to just base their prediction based on the sample mean alone, because different people with different samples will have different sample means. Okay, I'll show you something interesting. Let's say you recruited 10,000 people to do this exercise for you, and each of them picked up a sample of, maybe we'll increase the sample size, so each of them are allowed to take maybe 16 people. Okay, and so this is the first person took a sample of 16 people, and they get a sample mean which is sitting here, and then the next person, and so I have 10,000 people picking up 10,000 samples, although this is unrealistic. In the real world, we are just allowed to take 1 sample, but let's assume we are allowed to take 10,000 samples. So here what you see is all these blue bars represent some sample means, and there are 10,000 sample means here. So this distribution at the bottom, this blue one, is basically a distribution of sample means. Now what is interesting here is you note that the mean of all these sample means is actually 16. It turns out to be 16, which is exactly the same as the population mean. So that's very interesting, because we got the same population mean as the mean of the sample means, right? And the other interesting thing here is actually this particular distribution has quite a little, smaller variation than the population dispersion or variation. Okay, it's much more tighter, but that is expected because you have already averaged things out when you're piling them here in the blue distribution. You have taken a lot of averages here. So the lesson for here is, we get out of here is that the sample mean you or I got would be somewhere in this distribution. So if I just go back to my slides, and look at this whole thing we just did. So we got this 10,000 sample means, and But we are not allowed to take 10,000 sample means, and that is the problem. We just have one sample mean. And the sample mean you or I got could be anywhere here, or let's say we can be also here, or we can be right in the middle. But we don't know, we have no idea where we are when we take the sample and get a sample mean, okay? That whether we are closer to the population mean, which is exactly in the middle, okay? Or we are on the right-hand side or left-hand side of it. But what we see here is, no matter where our sample mean is, it is a few standard deviations away from the population mean, okay? So that's the key lesson here, that it's a few standard deviations away. And how many standard deviations away, that is the key, okay? And so basically, mathematically, we can show that the mean we have calculated, which is x bar, the sample mean we got, and we are trying to make a prediction about the population mean, which is mu. So we got the sample mean. For example, with the McDonald's customers, this x bar would be 55,270. Okay, so that's the sample mean we got. The rest of it is the margin of error, which is basically how many standard deviation I am away from the population mean, or I could be away from the population mean. So this part is the margin of error, and that basically is a few standard deviations, and in this case it's called t. That's the number of standard errors you're away from the population mean. So our prediction includes this margin of error part, and again, as I discussed before, this part, or the margin of error part, depends on three things. Number one is your sample size, which is, you know, generally denoted by n, which is the sample size, and then the second one is your variability, or what's the standard deviation, how variable the responses are within the sample, and the third thing is your confidence interval, which is, you know, generally a 95% confidence interval is used, but we can use other numbers as well. But we don't have to worry too much about the formula itself, because StatTools does all these calculations for us, and it gives us that range, plus minus range, that margin of error. So all this computation is done by StatTools. So we'll just go to StatTools and see whether we can make a prediction for the customers of McDonald's, what the average salary of them would be in the population. So if we go back to our StatTools data again, remember when we did the one variable summary, we just got the sample mean, which is the sample average, but now we are asked to make a prediction about the average of all customers in McDonald's from this sample. So the function we use here is called statistical inference. So again, we click on StatTools, and then we don't go to summary statistics this time, we go to statistical inference, and we choose confidence interval. And in confidence interval, obviously we are predicting the mean, so we just choosing that function here. Okay, confidence interval for the mean. Now you just have to identify the variable you're interested in. In this case, you're interested in the mean of the income. So click on income, and then in the bottom panel it asks you which confidence interval you want to calculate. I want to calculate the interval estimate for the mean. So I'll just keep the mean box checked, not the standard deviation, okay, because I'm just interested to predict the mean for the population. You can see that by default, the confidence level is set at 95%. Now you can change that. There are other confidence levels indicated here. Otherwise, you can just type your own confidence level you want, okay? But let's retain 95% confidence level at this time and make this prediction. So once you click on OK, you'll see a new worksheet appearing. It gives you the sample size, which is 148 customers. The sample mean, as we earlier saw, was $55,270, but that was just the sample average. Now StatTools has done all these calculations for us to give us an interval estimate, which appears at the bottom here. And that part basically tells you that the true average in the population of McDonald's customers, the average income would be somewhere between $52,740 and $57,800. So from point estimate of 55,270, we are now moving to an interval estimate. So we make a prediction where we have a range somewhere between 52,740 and 57,800. So the average is captured within that range. Of course, this prediction is not bulletproof. It's not 100% guaranteed. It's made with a confidence of 95%. So that means there's a 5% chance that the true population average is outside this range. And that's what exactly pollsters also tell you, that they make a prediction with a 95% level of confidence in most cases. That means there's a 5% chance that the true proportion of people voting for a certain party will be even outside the range given by the margin of error. Okay, so the prediction has a lot of uncertainty. So if you want to change the confidence level, let's say you want to be more confident in your prediction, you change 95% to 99%. You can change it right here, and you will see that the lower limit and the upper limit immediately changes. And now the prediction is that with 99% confidence, you can say that the average income of McDonald's customers will be between $51,930 and $58,610. But the confidence interval has gone wider as we expected it to. So this is the way we make predictions with stat tools. We don't have to do any hand calculations or use any formulas. We just have to know how to use the right functions to get the answer we are looking for. Thank you.